So in this last video of SLBAccademy Academy of this weekend, we are talking about magnetic resonance log. Nuclear magnetic resonance log and NMR logs are advanced wireline log tools that provide detailed information about the pore structure and fluid types in subsurface formation. They are especially useful in petrophysical analysis, reservoir characterization, and fluid typing, particularly in sandstone, carbonate, and shale formation. The magnetic log resonance, also known as nuclear magnetic resonance, are advanced wireline logging tools that provide detailed information about the pore pressure and fluid types in subsurface formation. They are especially useful in petrophysical analysis like reservoir characterization and fluid typing, particularly in sandstone, carbonate, and shale formation. The most frequently used application now are porosity estimates, Earth's water saturation determination, permeability prediction, residual oil estimation, hydrocarbon typing, and also oil viscosity estimation, T1 and T2 time relaxation time, permeability estimates, and free fluid index. What do magnetic resonance log measure? NMR logs detect the response of hydrogen protons in the pore fluids when placed in a magnetic field and pushed with the radiofrequency energy. Total porosity, free fluid index, bound fluid volume, T1 and T2 time relaxation, especially T2, which is commonly plotted, and permeability estimation. So this is an example of formula that we can generally use in permeability. For example, we have a differential movable versus immovable fluid. We have also an analysis of fluid movable, identification of zone that is probable, estimating permeability, fracture and matrix porosity in carbonates, clay bound water versus capillarity bound water in shales, calibration of the other logs, density, neutron resistivity, permeability modes like Timur's cost equation, SDR mode, Schlumberger-Dorisation, and we have also an integrated with logs like Insight, validate water saturation, cross-check porosity. We can do this integration, for example, for other types of log, for example, with resistivity, validate water saturation estimates, neutron density, for example, for cross-check porosity, sonic, correlate with the rocks stiffness porosity, FIM fracture logs. Understand, for example, in MS fracture logs, we can understand the porosity fracture relationship. So we also the possibility to improve permeability models like Timur cost equation, SDR model, and where is also the porosity from MR. Is the geometric mean of T2, ACM, and are empirical constant. Magnetic resonance log, we have also the possibility to improve this kind of log with neutron and neutron SCP log. So this is the instruments. We have the neutron probe with the source and detector. The neutron SCP can be applied for mineral logic application, water and also engineering, like ecology identification, or detect local aquifer and aquitard, shale content, correlation between open and case-old logs, strata correlation between wells. So this is the best application of neutron SCP logs. strength to geology and hydrology and hydrogeology. We have also the magnetic and resonance logs for formation density, like bulk density, dual calibrate density channel, and natural gamma. So we have mineral density and porosity, lithology, bed thickness, and boundary location, coal, ash, and moisture content. Source like this, also water or aquifer and aquifer, detection of cavities, and missing cement. So we have also an identification of missing cements. Engineering application like rock strength and elasticity parameters with sonic log, detection of water or fracture zone, and other else like this. So in this case, through this we have density and porosity, coal and moisture content. So we have also a case of study porosity and permeability in London clay. This is a state case of porosity and permeability in London clay and soft sediment in London. The NMR technique is really efficiently logged both to detect porosity and permeability, and can distinguish between mobile capillary bound and clay boundary water. It is effective in the air, water, or drilling mud, and is less sensitive to variation in boreal condition than other techniques. Techniques can be used in uncased or plastic fiberglass cased hole, even when grouted, eliminating the risk of boreal collapse, which often prevents the deployment of methods reliant on a radioactivity source, such neutron porosity. NMR is full well suited to a wide variety of ground conditions, including soft superficial sediments, clay carbonates, sandstone, and other sedimentary rocks. The method can provide unique information in certain geologies, in uncertain geologic conditions, where parameters can be derived, or the downhole techniques could be fundamental flawed to boreal condition. And we have also a good correlation with lithology from NMR log that is helpful to make measurements independent of variation in lithology and do not really upon empirical lithology specification correlation. This is an important advantage for designers need accurate, robust, and reliable data on the saturated water column and hydraulic properties. Using NMR data, formation porosity variation can be accurately measured on, and there is great potential to derive permeability, range, and porosity and permeability. So the last is dual neutron. This is the instruments that is different between the previous, because it is one source. In dual neutron we have these two sources and two receiver. Is one source, first source for neutron, and LS source for second source for neutron. So we have a real-time checked porosity. We're in borehole. Neutron count, natural gamma ray, a great application also in mineral exploration and water. Strata correlation between wells, correlation between open and case-hole logs, fracture analysis in coal. So it's clear that there will be an advance using, for example, magnetic resonance and formation AKD to estimate the volume, for example, of clay, or also to estimate the presence of water, and and make it easy to do the calibration with other logs. Thanks for attention. We make focus on next week in 5 and 6 appointment to Slumber Academy. Focus on particular application of logs, and especially to not so oil and gas, but also to petrophysical and mineral exploration.